Bai. Please, let's welcome Professor Bai to give us a talk. So it's all yours, Professor Bai.
Okay, thank you, Professor He Zhou, for your kind introduction. So it's my great pleasure to have this opportunity to introduce my research in this workshop. And yeah, my name is Quan Bai. I'm from University of Tasmania. So if you probably don't know Tasmania, but actually Tasmania is a state in Australia. So Australia is a mainland, but Tasmania is an island. Okay, it's an island state in Australia, and we are based in the capital city of Tasmania, which is Hobart. And here is actually my office building. I'm in level 4 actually. Okay, so a little bit about myself. So I'm currently an associate professor at the University of Tasmania. Meanwhile, I'm also the leader of the AI research group of UTAS. Before I joined UTAS in 2019, I was working at Auckland University of Technology in New Zealand. And before that, I worked as a postdoc in CSIRO, Australia. All right. My research is mainly focused on multi-agent systems, data mining, agent-based modeling, different type of applications of artificial intelligence, distributed AI systems, etc. Okay. All right. So today my talk is mainly about influence modeling, and I want to introduce different types of technologies which can model and simulate influence propagation. So influence is a very, it's in your daily life. So it's a very common phenomenon in social network. So influence is actually a kind of force, okay, you can call it force, that one individual tend to take some behavior or make some decision based on the behaviors of the surrounding environment or maybe the surrounding neighbors. Okay, so it can be many things. It can be a kind of purchasing behaviors. It can be a kind of decision making. It can be a kind of emotion, etc. Okay, so and we have a lot of influence propagation applications. For example, in the marketing environment, we have what we call viral marketing, or they try to use for example, word of mouth to help them to promote some product. Okay, and of course, in political campaign, influence modeling is also very important. And another thing is actually for example, for HR management. Okay, so for example, for some hunting companies, they try to recruit some suitable person. So they actually also need to use influence propagation to help them to influence the people they want to recruit. Okay, so yeah, and influence modeling is also not a new topic. So it actually initially from social science. All right. So in social science, people or researchers, they already start to work on, how to model the, humans' behavior of influence propagation by using some mathematical or formal method. All right. And a typical example will be, is a kind of probability-based model. All right. So for example, normally this model is called IC model. Okay, the IC model is a very traditional or classic influence modeling method. What they assume is we have different V here represent a user in a social network, okay, or a people in a social network, and they assume actually between different nodes, there's a probability for one user is actually can influence the neighboring, the neighbor of the user. Okay, for example, VI has a probability Pij to influence Vj. All right, and then what they do is actually they normally assume the overall topology of the whole social network is available, and in each step they just try to simulate based on the predefined probability value, okay, to see what will be the after each round, then what will be the new status of the whole social network. Okay, so this type of approach has been applied for many years, and it's very popular in social science, but it also got some limitations. For example, you can see it assumes the availability of the global view of the topology. So that means you need to know who are good friends or who are the neighbors of each nodes. And another thing is you can see the behavior rules are too simple because they only use a probability value to represent the influencing events. Okay, so which means they assume the same type of relationship among different neighbors. Of course, they may have different probability values, but eventually the influencing behavior is actually similar. So because of these limitations, it's somehow not very practical for many real-world applications because normally for many real-world applications, we don't have a global view of the topology, and the behavior rules is also much more complex than a simple, probability value. Based on these motivation, then we try, because my background is multi-agent system. Okay, actually, I'm purely from the computer science or AI background. So we try to use agent-based method to model influence propagation. Okay, so then we consider a social network as a kind of multi-agent system. Okay, so if you in computer science, actually we consider multi-agent system is a kind of is a collection of intelligent entities, okay, or intelligent systems, okay, and the whole system contain a number of these intelligent systems, okay, which is called agents, all right, and each agents they have loosely coupled relationship with others, okay. Meanwhile, each agent only have a local view rather than a global view. Okay, so in influence propagation modeling, we use different agents to represent different users, okay, in human users in a social network. All right. Okay, and then furthermore, we also define different type of behaviors. For example, we define different what do we call states for each agent. Okay, for example, if you have a kind of opinion and propagating in a social network, and then we believe each agent can either hold a positive or neutral or negative opinion on that particular information. Okay, and each agent, yeah, they have neighbors, and on the other side, each agent are under certain what we call social pressure. So this social pressure is actually can be calculated by how many by the opinion hosted by the neighboring agents of this particular agent. Okay, so which means if more agents they are holding the same opinion, so then this agent is having higher social pressure to also hold that particular opinion. Okay. All right, and yeah, we also define what we call prior commitment level or PCL for each agent, which means okay, at the beginning, so what will be the initial opinion of the agent? Okay, so then you can see based on this agent-based model, and then we try to use this model to simulate the influencing phenomena. Okay, actually related work has been published in a few papers, and if you are interested, you can have a look. Okay, so why do we need agent-based modeling for influence propagation? And actually, by using agent-based propagation modeling, we can simulate or model more complex scenarios. Okay, for example, in the classic example, normally it only can be used to simulate the propagation of a single opinion or single message in a social network. But in reality, actually, we normally receive different type of information from different resources. Okay, so we are influenced not only by a single message, we are influenced by multiple messages. We heard about news about sports, we heard about news about political news, we heard about news about economic news, etc. All right, and a lot of messages are quite related. All right, so we are not only every day we are not only receiving a single type of message. Okay, so then we actually start to propose a model called multi-influence propagation. Okay, actually, we have an example, inspiring example here, but yeah, maybe I don't have enough time to go to very detail, but the example is actually one motivation example is actually we found in the real world there are actually some organizations, okay, or maybe some individuals, they try to utilize multi-influence, okay, propagation to help them to deal with some, something like emergent scenarios. Okay, for example, if there's some negative information about the company is circulating in the social network, and these companies sometimes try to start to actually propagate another totally irrelevant message, all right, but also very attractive message. This is actually to distract humans, attention to from one negative news, which is about their company, to another irrelevant thing. Actually, not only company, but also sometimes government or some individuals, they may also do the same thing. Okay. So we try to use agent-based model to simulate and also model multi-influence diffusion. Okay, and then we actually based on the agent-based model we proposed, and then we modify based on the latter model, and we make it, the model be suitable to simulate the propagation of multiple influences. Okay, for example, beside each agent, we also believe this agent have a kind of repository. This repository actually hosts all different informations received from the social network. Okay, and the user agent can also receive different types of influence messages. Okay, in different topics. Okay, but all these message will then eventually hosted in the repository. In this repository we call it the wall of social network. Okay, and based on the time arrived, based on the arrival time, actually you can see the old message will be weakened, and also the new message always, sometimes always, occupy the top, position in the repository. Okay. We also consider different relationships. For example, we consider the trust relationship between different human users. Okay, whether you trust that person. If two user agents they trust each other, that means it's more easier for them to get or to have the same opinion of the other person. Okay, we also consider the relationship of user and influential message, because different people, they may have different preference. For example, they may have different hobbies. All right, then based on the profile, actually based on their preference and profile, then maybe they have different acceptance levels for message in different topics. Okay, for example, if you are a soccer fan, and then it's much easier for you to pay attention on the news about soccer. Okay, but then it may a news about basketball may less attractive for you, something like that. Okay. We also consider the relationship between different message, because some message they can be in the same topic, but they are actually quite, against each other. All right. For example, someone may say, okay, I want to support, for example, Chicago Bulls. All right. But someone want to say, okay, I actually want to support another NBA team, for example, Lakers. Okay, but Lakers and Bulls actually is again same topic. It's all belong to NBA basketball news. However, the message about supporting Chicago Bulls can be quite different, or even against the message about supporting, Lakers. Okay, so yeah. Then based on these relationships, we actually oh, sorry, this is a different. We actually can simulate the propagation process of different topics of influence. Okay. Actually, we also have some publication in this topic, but is that this one? Oh, yes, this one. Okay, yeah, this one. Okay. And we also, based on this one, we also can propose some strategy, not only to maximize a kind of influence message, because traditionally people always work on influence maximization. Okay, because this, for example, for marketing, people always want to maximize the influence with a limited size of seats. But by using this one, we can even define some strategy, not only maximize, but also minimize some undesirable influence messages. Okay, actually all these details can be found in the publication we published. Okay, all right, yeah. Besides multiple influence propagation, we also work on some other applications of agent-based influence modeling. For example, we work on what we call proactive recommendation. So proactive recommendation is different with traditional recommendation system. So normally traditional recommendation system only consider the human user's preference. All right. So which one you prefer, then we try to give you, or we try to predict the items that you are interested at. But for proactive recommendation, we not only look at the preference of human users, we also try to utilize the influential relationships in social network. Okay, so for example, if we want to promote some product, we try to, encourage the big nodes in a social network to, start to take this type of, or purchase this type of product, even with a bigger discount or etc. Because we understand if this guy actually purchase or start to use this product, it actually can influence more buyers to buy the same product. Okay, so this is actually what we call proactive recommendation. We also work on the effect, the phenomenon of filter bubble. Okay, filter bubble means if someone keep receiving the information that he or she is preferred, that means actually the person will more likely be very biased, okay, or have a very narrowed view about the information. All right, so actually we also wrote a paper, published a paper in EJK 2022, and that one is particularly talk about how to model the phenomenon of filter bubble and how to even get some mitigation strategy based on that. Okay. All right, so this is agent-based modeling. All right, and start from last year, suddenly we also have something like a lot of large language model tools become very popular. For example, ChatGPT, we have Copilot from Microsoft. We also have a lot of similar product from Google, or even some Chinese company also propose some large language models. Okay, and this large language model is actually especially good in handling and also generating language data. Okay, natural language data. All right. So then we think about, all right, whether we can also utilize some function or some power from large language models to help us to do even better influence modeling. Okay. So as what I introduced, so you can say agent-based modeling is much more complex than the traditional probability-based modeling. All right. But from the other angle, you can still consider agent-based modeling or agent-based influence modeling is a more advanced or more complex probability-based modeling. Because we modify we define agent, okay? We define different behaviors for agent for accepting or rejecting a type of message, okay? But all these behaviors, all these reasoning rules are also based on probability, which is a kind of numerical value, okay? So then one thing is missing is in real world, we always, read some message and try to understand the message, and then something like modify the message and post it, or send it away to our friends. Okay, so but in the agent-based modeling, I just introduced the content of information. Okay, actually has been ignored, but it actually play a very critical role in individuals' decision making. Okay, so then based on this motivation, we think, okay, we propose another simulation tool. This is called LLM, large language model enhanced agent-based influence modeling. Okay, and the architecture is like this. Actually, it's very similar with the agent-based model we proposed, but the only difference is the message. Each agent, after they receive a message, okay, this message actually will then be sent to a large language model engine. okay, to see, okay, based on this one, what would you think? Something like that. Okay, so every time when agent receive information, it will send the information to a large language model. We try to simulate the reasoning, the language reasoning behavior of human. And then from large language model, this agent will know, okay, what will be the message I'm going to propagate to the next layer, to other neighbors of this peer. Okay, so we just recently, just give me a second, okay? We just recently actually have a demo paper accepted by EJK 2024. So actually, let me change the shared screen. Because this paper just got accepted, so actually I think except the reviewer, we haven't shared it with anyone, okay? But basically, so to share my computer audio.
Ideas, opinions, and information in many applications, like viral marketing, minimizing misinformation, almost probabilistic and alter net behavior.
Here.
Our proposed model aid is illustrated as follows. A social network user is modeled.
Can you hear the computer audio from my computer? Can you hear the
Yes,
sound?
yes, we
Okay.
can hear.
Okay, no problem.
As an autonomous agent with a personal profile and complex behaviors. A user agent is probabilistically
And you can see the video I shared, right? The YouTube video, right?
Yes,
Yeah,
I see
everything's
it.
okay.
Okay,
accept
good.
an influence message depending on both the influences from its social connections and content of the message. Meanwhile, if a user agent is influenced, it further propagates the influence message based on its profile to its neighbors. LLM is developed based on an agent-based simulation framework, Melody, and its visualization tool, Melody Studio. Once the Melody Studio server starts, we can run our simulations. On the left side of the web page is the toolbar and parameter components. The toolbar provides 4 buttons to control the model simulation for resetting, stepping to the next time step, looping, and pausing. It also shows the current time step. The parameter space lists the parameters that can be adjusted via this space. In LLM, we consider 2 parameters, the seed size and the influence parameter. Both can be adjusted by tool users. In our scenario, Agent 45 serves as our seed user with the initial influence message. Introducing our latest product, the Smart Home Hub. Seamlessly control all your devices, from lights to thermostats, in one central hub. Enjoy energy savings, convenience, and security. Compatible with popular smart home platforms. Upgrade your home today and experience the future of intelligent living. Available now at authorized retailers. The network type here is an Erdős-Rényi graph, but it can be of any network type depending on the setup. Scenario 1 is based on a social network with 50 nodes, which each node has a probability of 0.1 to connect with each other. Active user agents are represented in green, while inactive ones are in yellow. The network supports zoom in, zoom out, and hover functions. When a node is hovered over, it displays information about the node, including the user ID and state. When hovering over an edge, it shows information about the connection between 2 nodes. By the second step, influence coverage and alteration degree plots become visible. The green and brown lines in our coverage plots denote the number of active and inactive user agents for each time step. By time step 3, the diffusion process completely converges. Detailed influence information is printed on the console, including the user IDs of influencers and accepted users, along with the messages that influence them. Moving on to our second scenario, focusing on election candidacy, where we've utilized only 20 user agents to expedite the process. We can also adjust network parameters. Let's set the influence parameter to 0.1 and the seed size to 2. As a result, we now have 2 seed users with the same message, amplifying the diffusion process. The diffusion process continues, with the color of node slowly changes. At step 3, none of the users are accepting any messages, leading to flat coverage and alteration lines. The posted information of user agents are distinctive with respect to their personal profile. Now, let's run our third scenario, spreading new idea, with the same network size. At this stage, there are no neighboring user agents for both agent 17 and 0 to propagate the messages further, resulting in no further diffusion. This is expected given our network type is random. Upon resetting our network, we observe the diffusion process occurring as anticipated. The influence coverage converges, suggesting information propagates over time, and this process stops if there are no more user agents that can be influenced. Due to the nature of a random network, two nodes are isolated. However, it can be seen that influence messages diffuse among connected user agents. The console shows the messages that are posted by these influenced agents. Also, the decreased alteration degree suggests that the contents of user agents' posted message execute our final scenario, a simple general conversation with the same parameter settings. This time, the alteration degree is notably high compared to other scenarios, and the diffusion occurs swiftly as well. Scenario 4 is a relatively open-ended question, asking user agents, "How are you today?" The console prints user agents' responses, which reflect their personalities. For instance, user 19 feels blissful and refreshed after her yoga session, while user 14 feels motivated and energized after a morning hike. In this demonstration, we presented an LLM-enhanced agent-based simulation tool, LLM, for simulating information propagation in social networks based on our proposed diffusion model, LLM. We showcase the advantage of LLM in representing language-level behaviors of social network users through simulations of 4 scenarios. Additionally, we highlighted the ability of LLM to simulate information propagation in various application settings. In the future, we plan to extend this work.
Yep, so this is actually the third modeling technique. Just give me a second, just share my PowerPoint again. Which is actually large language model based, large language model enhanced agent-based influence modeling. Okay, so but this one actually you can see different with if we only use agent-based modeling to model influence propagation, this one can give people or decision makers a lot of semantic information, language information about the content behind the information propagation. Okay, another thing is because in real world, actually, when information are propagated in social network, the information got changed again, got changed as well. Okay, because each human user, they are not only passing the information to the next peers, they also modify the information based on their own preference or understanding or knowledge, etc. Okay, so this actually can, by using large language model, we can help to simulate, the possible change of the influence message in the social network in the propagation process. Okay. All right. So this is the end of my presentation today. So in general, actually, I introduced the problem of influence propagation modeling, and I introduced, 3 different types of propagation modeling method. The first one is actually probability-based, which is a classic propagation modeling method. And then based on that one, we also introduced the agent-based influence modeling. Okay, and with a large language model, we believe actually agent-based influence modeling can even achieve more. Okay, can even achieve more meaningful simulation result to support decision making and also predict some possible influence message evolutions in the social network. Okay, and that probably can give decision makers more meaningful information about the strategy for send out or propagate some information. Okay, yeah, thank you very much.